So welcome to this meeting. This session is about answering questions in relation to the topic of atomic structure. So we will use the questions available in Save My Exams, and these questions vary in their difficulty from easy to medium to hard. So we'll start with the first set of questions, and these are the easy questions. So the first question says, in 1808, John Dalton published his atomic theory. This was the first complete attempt to describe matter in terms of and contained four theories. Which of the theories is still considered to be correct today? First, all matter is made of indivisible atoms. Two, all atoms are very small in size. Three, all the atoms of one element are different in mass from all the other atoms of other elements. And finally, all atoms of the same element will have the same mass. So the correct answer here is C, B, because basically the other ones, they have been proven incorrect with the development of science. The second question here is, the reaction between shown occurs in gas cloud throughout the universe. And this reaction is basically hydrogen gas with hydrogen gas ion. This gives the hydrogen as a single atom with H3 plus ion. So the question here is, what is the atomic structure of this ion, H3 plus? Here, note that we have three hydrogens, and these three hydrogens, that means we have three protons, and we should have three electrons, but the electrons here are -1 because one electron has been lost. So basically, the correct answer is B, because you have three protons and 2 electrons and 0 neutrons. Which of the statement is correct? For 3 of them, the atomic number is the number of, obviously the atomic number is the number of protons, and the proton number is the number of, obviously the protons as well, and the mass number is the number of nucleons. Nucleons means the content of the nucleus, which is the protons and neutrons. So the correct answer is D. Okay. So the next question here is, which option correctly describes the relative charge of mass of subatomic particles? So a proton is +1, neutron is 0, electron is -1, that's correct. But the relative mass of the proton is not 1, it's 1/1840. And therefore, basically, this answer is not correct. So the proton's charge is 0. No. Proton charge is +1. That's correct. Neutron is 0. Electron is -1. And relative mass is 1/1840, which is correct. So the correct answer is C. Question 6 says the trajectory of subatomic particles shot through an electric field produced in vacuum are shown in the diagram. So basically here you have proton or charged particles that are shot through electric field. And the rule here is these particles, as they're shot through the electric field, they'll be deflected according to their basically mass and according to their charge, based on the charge to mass ratio. And if it is a proton, if it is a positively charged, it will be deflected towards the negative charge of the plates or the electric field. And if it is positive, it will do the opposite. And if if they were neutrons, so the neutrons will just pass through without deflection. So here we have the protons are obviously will not be deflected towards the positive, so this is wrong. Neutrons that are neutral, they'll pass through without deflection, correct. And electrons, they'll be deflected towards the positive. So we have the 2 and 3 answers are correct, which is A, as you can see. Okay, so next question here is which of these rows is correct? So here we have a description for the nucleus and the surrounding space. Small, the nucleus small, dense, and neutral. It's not neutral. And the surrounding space, mainly space, yes, but this statement is incorrect. Large, dense, positive, no, because it's small. And densely populated with electron, it's not correct. Large, dense, and neutral, it's not neutral, so this statement is incorrect. Small, dense, positive, yes. Mainly empty space, yes. So the correct answer is D. Okay, so question 8. X is a particle with 19 electrons and 20 neutrons. So the 3 spaces are shown below. So it's calcium +1 and the ion of potassium and the atom of argon. So which atom is the correct one? So basically we know from the periodic table that the calcium has 20 protons. We know that the potassium has 19 protons, and we have the argon as 18. So basically the only one that fits this criteria is calcium +1, because if you were to do the other ones, you will find that potassium has 18 electrons, not 19 as stated in the question, and also you will find the argon has 18 electrons, not as stated in the question. So the only element that has 19 electrons is the calcium +1, because originally the neutral, if you like, the neutral atom of calcium has 20 electrons. But here basically you have +1, that means you've lost 1 electron, and therefore basically you've got 19 electrons in total. So the correct answer is 1. Okay, the next one here, which of the following statements describe the first ionization energy? So the first one, the energy required to remove 1 mole of electrons from 1 mole of gaseous atoms. Okay. The second one is the energy required to remove the outermost electrons from atom in the mole of gaseous atoms. So this is more precise than the second one, than the first one. So here we will take B as the correct answer, because it has mentioned the outermost electrons. Okay. And whenever you define the ionization energy, you always need to mention that it is 1 mole of electrons, and also it's removed from the atoms when they are in the gaseous state. Okay. So the next set of questions are the medium sort of difficult question. And the first question here is, in which of the following species the number of protons, neutrons, and electrons are different? So here we have Na plus, and the atomic mass is 23. Aluminium is neutral. The fluorine is -1, so we call it fluoride ion. And here we have the S -2. In this case, the correct answer here is plus the Na+1, the ion of sodium. And in this case, you will find that has 11 proton, and the number of electrons will be 10. In case of aluminium, you will find that that the number of electrons and protons are equal, each 13. In the case of the fluoride ion, you'll find that the number of electrons and neutrons are 10 each. And case of the S-2, you'll find the number of proton neutron equal with 16 each. So my advice here is sit down and pause the video and do the calculation just to double check that this is the only one where the number of proton, neutron, and electrons are different. Question 2, the atomic number of the element gives the number of protons in the nucleus, which is also equal to the number of electrons. Which statement explains why atoms are neutral? So the first option here, one proton has a mass of 1840 times greater than the electron. The charge of electron is equal to the opposite charge of the proton, which is the correct answer. And then the difference between the difference in charge between electrons and protons is balanced by neutrons. It's not correct. And electrons are spread out in shells around the nucleus, while protons are concentrated. Also, this is not correct. Number 3, which of the statements correctly describes the trend of metallic radius in group 1 elements from sodium to rubidium? So, as you know, as you go down the group, you need to add more shells to fit the more electrons in, and therefore basically the size will increase. So increasing moving down the group, okay, but we'll see the next one, increasing moving down the group due to the addition of electron shells. So this is basically more accurate than the first one. And then also we look at decrease moving down. This is not correct. So the options are 1, 2, 3, 2, 3, 1, 2, and 1 only. So the 1, 2 are correct. The second one is more accurate or more precise than the second one. So always you need to be careful when you look at these type of questions, because the requirement can differ from one question to another. Okay, the next question here, which statement correctly describes the distribution of mass and charge in the atom? First, the negative charge is concentrated in one area outside the nucleus. No. The mass is concentrated inside the nucleus. It's correct. And the mass and the negative charge is spread around the outside the nucleus. That's correct. So the correct answer is 2 and 3, which is C. Okay. Question number 5. There are 6 unpaired electrons in atom of element Z. What could element Z be? Is it sulfur, iron, chromium, carbon, or chromium? So the correct answer is chromium, because when you do the electronic configuration of the chromium, you will find that the electrons are unpaired, the 6 electrons. So basically, to answer this question, you're required to do the electronic configuration. Okay, next. The second ionization energy of magnesium is 1451 kilojoules per mole. Which equation correctly describes which equation correctly describes or represents the statement? Well, here they are talking about the second ionization energy. So to go through the second ionization energy, you must go through the first ionization energy. So this is basically if you look at option B here, this magnesium ion has already gone through the first ionization energy, or became ionized by losing 1 electron, and now it is losing its second electron. And this is basically is the correct answer. Question number 7. Here in these 3 diagrams, we have the orbitals of S, P, and Y. So the questions here is which of these statements is correct. So this is basically S. This orbital is Px, and this one is Py, and therefore the correct answer is C. What is the electronic configuration of the ion with a single negative charge, and the atomic number is 17? So if it is single atomic charge and the number is 17, that means you have to add an extra electron to this, and this will be 18. So the correct answer will be the B. And if you look at the number of electrons here, it will be 10 and 8, which is 18. Because here you have to add an electron because this species is negatively charged by the magnitude of 1. Okay, and then question 9. Which is the correct sequence for the orbitals shown in the atom of vanadium in order to decreasing energy? So basically, to answer this question, you need to do the electronic configuration. And when you do the electronic configuration, you're basically starting with the lowest energy to the highest energy. But here is asking you to do it in the reversed manner. And therefore, basically, when you do so, you will find that you have the 3D, 4S, 3P, and 3S. This is the sequence of orbital energies in a decreasing energy manner. Okay. The last question in the case of the medium difficulty question. The isotope CO2760 is used to treatment cancer cells in the body. Which statement of the following is correct? The charge on the nucleus is 27. There are 33 neutrons in the nucleus, which is this and this are correct, and has same number of neutrons as other isotopes. So number 1 and 2 are correct, and then it cannot have same number of neutrons because isotopes basically by definition they must have different number of neutrons. Okay, next is the difficult questions or hard questions. The species Cl minus, K plus, and argon are isoelectric. When it says isoelectric, means they have same number of electrons. This means that they have same number of electrons. So in which order do their radii decrease? So here you have the only thing that controls the radius is the nucleus. And therefore, as the atom becomes more positively charged, this will make the atom to get smaller because the electrons, they will be attracted more towards the nucleus. So the largest here is Cl minus because it has an extra negative charge, then the neutral, then the potassium ion, which is the smallest because of the presence of the positive charge, since the number of electrons is not playing a role here. Okay. This question here says the trajectory of subatomic particles shot through an electric field produced by vacuum are shown below. The velocity is the same in the three particles. Number one, proton and electrons are deflected because they are charged particles. This is correct. The neutrons are undeflected as they have no charge. This is also correct. And the electrons are deflected more than protons because they have less mass. And this is correct because the deflection is based on the charge to mass ratio. So as the particles becomes lighter, it will be deflecting more. Okay. The atomic radius of element decreasing moving on period 3, across period 3. Which of the following statement explains this phenomenon? Electrons shells are added moving across the group, which increases the nuclear charge. No. The nuclear charge increases as we move across the group. This is correct. And also there is great force of attraction between the nucleus and the electrons, and this is also correct. And therefore, the answer is C, which is 2 and 3. Element X is in the period 2 and has first 7 ionization energies. So these are the first 7 ionization energies of any element here, and element X in period 2. And these values are given in the energy of kilojoules per mole. So which is the electronic configuration of X? As you can see in this in these values, there is a jump here between the fourth one and the fifth one. So you can see that there is gradual increase, 1,300, 3,000, 7,000, 5,000, 7,000, and then a big jump to 11,000. And basically this suggests that there are 4 electrons being ionized in this case. And then the fifth one is belonging to the 2s, because basically it requires extra energy to remove the electron that's closer to the nucleus. Okay, so the correct answer is A. The successive ionization energy of oxygen would be the highest jump expected to occur. So second ionization energy, first ionization energy, seventh ionization energy, sixth ionization energy. So in the case of oxygen, we know that it has 6 electrons. So it has 8 electrons. So basically, once you remove all the valence electrons, the 6 electrons, and in the case of oxygen, which is 1s2, 2s2, 2p4, once you remove the 6 electrons, then there'll be a big jump in the 7th one, and this is basically the correct answer, which is answer of C. So in this case here, the 7th ionization energy is the big jump in case of oxygen. Okay, so question 6. Which statement explains the similarities of chemical behavior for isotopes of the same element? They may have the same electronic configuration depending on their reaction. They have the same electronic configuration. Their mass number are different, and they have different number of neutrons. So the correct answer that they have the same electronic configuration, but their mass is different. 7. Which species produces half-filled set of p orbital on losing an electron? So if any of these species loses an electron it will form half-filled set of p electrons. So in this case, um, if the nitrogen loses an electron, so the p orbital, it will not be fully filled. And same applies to the other elements. And here, if you look at the nitrogen -1, if it loses an electron, which is this negative charge here, which is the -1, then this will result in half-filled electrons. So if you would like to see here, in case of -1, when it loses electrons, it will become like the electronic configuration of nitrogen, which is 1s2, 2s2, and 2p3. So this is what's meant by p3 here. p3, that means it has 1, 2, 3 unpaired electrons, means single electrons. Okay. In case of lithium, it doesn't have a p orbital to start with. In case of the fluorine and the N+, it will lose electron, and therefore it will not be filled. It will have like unpaired electrons, but they'll not be. It will not be a filled or half-filled p orbital, and in this case also it will be the same thing. Okay, next, which statement explains why electrons pair up in orbitals before occupying an orbital of higher energy? The energy from repulsion is greater than to jump to a higher orbital. Electrons occupy higher energy before the lower energy. Electrons in lower orbitals have higher energy. And the energy from repulsion is less than the energy from jumping to higher orbital, which is correct thing. So the energy to jump from one orbital to another is higher than the repulsion that's caused when the electrons are paired. And that's why the electrons, they would rather to pair up rather than to jump to a higher orbital. And therefore, the correct answer is D. The first ionization energy of beryllium is higher than first ionization energy of boron. And here we have 4 options. First option is boron has full outer shell. Second, the boron has a large atomic radius than beryllium. And beryllium has a more stable electronic configuration. And the atomic number of beryllium is higher than boron. So if we look at the electronic configuration here, you will find that in case of beryllium, it has 1s2, 2s2. And in case of boron, it has 1s2, 2s2, 2p1. And this basically gives the beryllium a higher sort of stability than the boron, and therefore it causes the ionization energy to be higher. Finally, the electronic configuration of four elements of different atoms are shown below. So which atom has the highest first ionization energy? So here you have the first atom, second atom, and the fourth atom. Now, this will be C. Here it will be the highest because you have the second orbital, which is filled. This atom is very stable, and therefore, basically, it will be the most difficult to ionize. Okay, so by this we came to the end of these questions. my advice is while you are answering, or if you have completely answered these questions, try to go over them again and try to pause the video and answer by yourself using the periodic table, the electronic configuration, in order to attain higher comprehension of these questions. I hope these were beneficial, and we'll see you in next video. Thank you.